Bill Nye the Science Guy. Bill Nye the Science Guy.
Whose f***ing idea was this? I mean, a top hat, okay, I get it, I'm supposed to be smart. But the bow tie. The fucking bow tie. Okay, quantum mechanics, also known as quantum physics, or quantum theory, is a branch of physics that deals with—
Cat! Stop. Okay, I'd like to remind you, this show is for people with ages 6 to 12. They don't understand this. I am a 20-year-old intern. I don't understand this. Oh, don't give me the hand thing. Okay? Your contract states you may discuss the topics found in the curriculum for their age level.
What the fuck does that mean?
Sorry, bro. Contract.
Non-existent, goddammit. You people with your rules and your intelligences. Ugh. Where's my manager? I have a sudden impulse to make neurons fire at an increasingly fast rate. Alright, give me 4.68 seconds to think. I'm sure I have the curriculum in here somewhere. Nope, not the curriculum. Nuh-uh. I'm pretty sure I don't want to remember that again. Alright, curriculum. The ecosystem. Nah, no one cares about our survival anyways. Okay, fluids. Boring. That. Don't want to get into that. Ooh, the formation of the Earth we know today. That way I won't be violating the curriculum, and I can get out of here sooner. Let's discuss the formation of the Earth we know today, which leads me to my first point. In our universe, there are interstellar gas clouds, which are mostly composed of dihydrogen molecules, with large densities and high heat signatures. In a gaseous state, at that temperature, the particles are constantly spiraling around each other, only to be held together by an electrostatic force, slowly bringing the particles together, yet at times failing to hold them together. Therefore, over a period of time, several rings form around the hottest and densest molecular cloud.
Oh shit!
Eventually, the molecules would cool and bond to form a flaming liquid molten asteroids that attract the rest of the molecules within the rotating ring while continuing cooling. Once the asteroid reaches a certain temperature, the outer layer solidifies to become a solid, also known as the crust. This does not apply to the Sun, which stays in a liquid/gas form due to its temperature and density. Now we have our solar system, which was only formed about 4.54 billion years ago. Let's skip to 750 million years ago. This is what Rodinia, the supercontinent at the time, looked like. Then, 200 million years ago, Pannonia formed. It looked like this. The latest known supercontinent is Pangaea. As you noticed, our planet changed, and if you didn't, you're a complete retard. This is because our crust is divided and full to top the liquid magma within our core, or surrounding our core. The crust or ground masses flow in different directions, and but at the same time possibly causing collisions. These ground masses are called tectonic plates, and if they collide, there can be some sort of natural disaster such as earthquakes, volcano eruptions, or tsunamis and whatnot, because people will go extinct anyways. Okay, now that we're done that, I get to clean up the body. Who knows where my manager is? Stupid body. God damn it. Get up. Shit. There! Oh crap, he's alive. Shit, dude, he's alive. Pass me the bat. God damn it. I think he's dead. Alright, he's dead. Hey. God damn it, stupid body. Ow! The body isn't there. The body isn't there.
Please forgive me for that stupidity, but here's some real science. Enjoy!
Flying past the Earth at this time, we see a vast gray ocean beneath a red-tinted sky, punctuated by volcanoes and small land masses. And unlikely as it seems, life may have gained a foothold already. That life in the oceans that gave birth to it may actually be vaporized many times by cataclysmic bombardments, which have slowed but not yet stopped. Earth has begun to take on its final form, a crust, a skin so thin it would be less than a sheet of paper were the Earth the size of a basketball. And under that, a molten semi-solid mantle that boils in extreme slow motion. And finally, two cores, a liquid iron core pulsing out a magnetic field that helps shield us from a deadly cosmic wind from our sun. And a solid nickel and iron inner core. By now, the remarkable process of plate tectonics has kicked into gear. Though how and when it started exactly, we do not know. For what follows next, you might want to strap yourself in. It's going to be a bumpy ride. Here's how it might have happened. At first, Cretans and one continent called had the planet all to themselves. Then, around 500 million years later, Antarctica took shape. About another 500 million years passed before Atlantica formed. The continents roamed separately until, about 1.8 billion years ago, Antarctica collided with what is now Eastern Antarctica to form Nina. Then Nina, Atlantica, and collided 1 billion years ago, forming the supercontinent Rodinia. After about 300 million years, the three landmasses separated and came back together in a new configuration, Pangaea. Pangaea came apart too. When Pangaea split, and Atlantica split up too. If you're confused, join the club. Even the Earth seems confused. All of this movement made for a host of unlikely neighbors way back when. North America's eastern seaboard once rubbed shoulders with Chile. California and Australia were neighbors, if not connected. And Brazil was either connected to Nigeria or very close. Run the Earth time machine backwards, and you can see why. But no matter how many times you run the demolition derby of the continents, a question remains. What the hell is driving them? Hell, apparently. The force driving the plates is the slow movement of the super-hot semi-solid mantle that lies below the rigid plates. Like hot soup, magma boils in slow motion. Superheated magma rises to the surface, begins to cool, and then sinks back down to the bottom of the pot, where it is reheated and rises again. This cycle is repeated over and over to generate what scientists call a convection cell, or convective flow. But where's the heat source keeping our earthy soup performing its circular gymnastics? Well, most of it is left over from the spectacularly energetic collisions and gravitational crushing that created the Earth to begin with. It's still trapped down there, and it wants out. And there's something else in the molten depths that makes it pretty hot real estate. Radioactive material. The belly of the beast has plenty of uranium and other radioactive elements, all of which release heat as they decay. That decay has significantly slowed the rate at which the Earth is cooling. So what does this mean at the surface? Two things. First, magma being burped up along the ridges, those places like Iceland where the Earth is tearing itself asunder, is pushing the plates in their respective continents apart. Second, what goes on at the other end of those plates, the collision zone, may be equally important. Here, where the heavier plates dive under the lighter ones, yanked downwards by gravity, they haul along their plates back into the oblivion of the mantle. That's what we know, or what we think we know. But the details of what's going on in the deepest parts of the Earth that drive the engine of plate tectonics, we may never know.